Approximation, limits of accuracy. Imagine if we were manufacturers of bricks and we wanted to manufacture a brick that was 215 millimeters long, 102.5 millimeters wide, and 65 millimeters in height. Now, because we manufacture bricks, we'll be producing millions of these, and not all of them are going to be exactly 215 millimeters in length, etc. But there's going to be some variation. There can't be that much variation because if the bricks are very too short or they're too long, it's going to be difficult to build a wall with them and make sure that they all interlock like this. So there's a certain tolerance, there's a certain limit that we can allow. So for instance, in this case of the brick, the ideal weight might be, the ideal length might be 215 millimeters. But we can allow a variation of say 5 centimeters. 5 millimeters, I mean. So this would be one end of the 5 millimeters, that would be the other end of it. And in the middle would be the ideal, the 215. So what would be the length of the upper bounds? Well, 5 millimeters, if it's spread equally, means there's 2.5 millimeters in this direction and 2.5 millimeters in that direction. So for the upper bounds, it would be 215 plus this value here, 2.5 millimeters. So the upper bound in this case for a span of 5 millimeters is 217.5 millimeters. This is just adding the ideal length with the with half of what we have as the acceptable deviation from this. And this down here will be 215 minus 2.5, and so millimeters. So this produces 212.5 millimeters. So simply taking away this deviation from the ideal. So this would be the upper bound, the upper limit, and this would be the lower bound, or the lower limit. So let's have a look at some examples of where we might be using this. So in a test paper, you might be asked, work out the upper bound and lower bound for the following measurements. So when you do this, have a think of that model that I just showed. So 32 centimeters is the ideal length of whatever we're measuring. And it says measured to the nearest centimeter. So this represents 1 centimeter. And as this shows that 1 centimeter divided by 2 is 0.5. So this distance is 0.5 and this distance is 0.5. So one is plus and one is minus. And all you have to do to find the upper and lower bound is to add 0.5 to 32 for the upper bound and take 0.5 away from 32 for the lower bound. So what is 32 plus 0.5? Well, it's 32.5, which is this. What is 32 minus 0.5? Well, that's this value. So those would be the answers. Let's have a look at this other example. And it says here, 140 centimeters measured to the nearest 10 centimeters. So you can think of it as 140 centimeters being the ideal, measured to the nearest 10 centimeters. So again, think of this as a scale like that, where the whole of this is 10 centimeters. So if the whole of that is 10 centimeters, then this would be 5 centimeters. You can say 5 centimeters. And this is minus 5 centimeters. And in order to get the upper and lower bounds, you just alter this value. So this would be 140 plus 5. And this would be 140 minus 5. And 140 plus 5 is 145. 140 minus 5 is 135. So you can see just how simple this is. And then as a third example, this is 8.4 centimeters measured to the nearest 0.1. So we do exactly the same. So 8.4 centimeters. Imagine that as the ideal. And then there's an upper bound, a lower bound, and this is all 0.1 centimeters. So what is half of 0.1 centimeters? So half of 0.1, so this is 0.05. So for the upper bound is plus, and for the lower bound is minus 0.05. And then quite simply, you just put the 8.4 there, 8.4 there, and 8.4 plus 0.5 is 8.45. So that's the upper bound. The lower bound, 8.4 minus 0.5 is 8.35. So really it's as simple as it looks. I want you to have a go now, and so do the usual thing of putting it on pause, having a go, turning it on, and then I'll work through it with you. So I'll give you a chance to have a go. So hopefully you've had a chance at giving this a go, and you've drawn a few pictures and things like that. So what is the upper bound and lower bound of 62 kilograms measured to the nearest kilogram? So again, just to help you, you can think of 62 kilograms as being the ideal, which is in the middle, to the nearest kilogram now. So we're going to draw these bounds in, and the whole of that is 1 kilogram. So if the whole of that is 1 kilogram, then half of it will be 0.5 kilograms. So that is a plus for the upper bound and a minus for the lower bound. And so 62 plus 0.5 is 62.5 kilograms. And this is the upper bound. For the lower bound, it's 62 minus 0.5, and that turns out to be 61.5 kilograms. And so that's the lower. So if you've got those answers, well done. So just as another example, what is the upper and lower bound of 390 grams measured to the nearest 10 grams. Same principle, that's 390 grams. That's in the middle. We can vary that by 10 grams, as it says here. Half of 10 is 5, so this is plus 5 grams. The other half is minus 5 grams. So if you add 390, or if you add 5 rather grams to 390, then you get 395 grams, and this is the upper bound. And if you take away 5 grams from 390, you have 385 grams, and this is the lower bound. So if you give these answers in a test, whatever, it would be correct. How about this last one? Hope you got those two right, by the way. What is the upper bound and lower bound of 15.89 seconds measured to the nearest 0.1 second? So the numbers will all change, but the principle is the same. So whatever the ideal is, which is 15.89, that's the ideal. The upper and lower bound measured to the nearest 0.1. So here we go. That's the upper and lower bound. If the whole of this is 0.01 seconds, then what is half of that? Well, half of 0.01 is 0.005. So 0.005 is half of 0.01. So again, for the upper, we add it. For the lower, we take it away. So if we were to add this value to the ideal, that comes out as 15.895. And so this is the upper. And if we take away this from the low one, then that becomes 15.885. And so this is the lower. So hopefully you've got those questions right. Any problems, just work through this again, or write a question in the comments or contact me.